Right, that little demonstration was to show you that, well, washing clothes and putting them on this drying rack isn't as simple as one would assume. These things are flimsy and they don't stick to each other in any way, and they always open up when you take the drying rack out to hang your clothes. So we should do something about it. Let's measure a bit. So first of all, well, maybe this is, let's see here. $11.2 or so. Yeah, 11.5 or so, 12 maybe. And then we have well, it's problematic that they're not exactly parallel all the way, so we have a bit more room here than we have here, but roughly 27 millimeters. So 11.5, maybe 12, and 27, 28. We should come up with something from scratch to remedy this. I think it's a good thing. It should be simple enough, maybe. For someone like me who is just learning the 3D modeling game. So let's get to it. Oh, and then there's of course the other problem with these cheap sort of racks. As you can see over here, these welds, some are better, some are worse. Like this one hasn't got too much. Well, this one has a lot of it's a large blob here. This one is sort of connected, but... And I've had racks in the years before failing with these things just coming loose. So that's also something we have to fix. But I don't know if I can fix it myself, or maybe we'll find some model for that. We shall have a look. But we'll start with this thing, because it's annoying even when these racks are not broken. I don't know why they can't supply you, when you buy them, with something that clamps these so they won't move around when you bring the rack out. But of course they want it to fail, so you have to buy a new one, I suppose. Anyway, let's get to it. Alright, so we are in 3D Builder. And, well, basically what I have done... So I didn't record this from the very beginning, because it was so... the current design, at least, is very, very simple. So, the rightmost ones, what I basically did was, I created a three-dimensional rectangle block, and I inserted two cylinders lying like this, and then I sort of reduced to get this design. However, I'm a bit so I'm not sure if this will work, but the thing is that I'm worried that in this first case that this won't grip the
the bars too well on the drying rack. So I did basically the same thing, only I elongated this a bit to give it a little bit more material here on the sides, so it won't bend too easily maybe. And also I pushed these cylinders down a little bit further, so we have a bit more of a curve here with an overhang to give a better grip maybe. But I'm still wondering, maybe I should do a little bit more still. So what if I select these both, make a copy, and then if we move it all, and let me just select, let's see here, yeah, these are grouped already, yeah. So let me just move, let's see here, let me just move these. Okay, so let me just drag it down manually a little bit more. I don't know how much, maybe like that. And then so make it, oops, make a copy, and then if I go to edit, subtract, I mean not reduce, subtract, and then this middle part, I suppose it will not print too well, it's too thin, and I think it's better to remove it like here. So what's the best way to do that? Maybe we can insert a cube. And that way move it. Over here. Yeah, and then we subtract. So something like that. Yeah, it looks pretty good. So I'm thinking maybe I should print well, I'll start with this one, and if not, then we can try this middle one if this is too tight or something, but hopefully it will be good. Now I'm a bit worried about distance over here. Let's see what we have. We have measure. Yeah, that's like 1.6 millimeters. So that's not much. So maybe I should make it a bit thicker. If I copy this instead, right, and then I remove that. Let's see here. This is 12 millimeters in total height. So if I make it, I don't know, 15 millimeters, maybe a bit wider as well. 35. And then I move, if I copy these tubes or cylinders. Yeah, in that case, it will be a little bit much here, maybe. So I can move them up a bit. It's a bit, yeah, to get a good overhang without overdoing it. If I do it something like this, maybe, and then I subtract, yeah, and then we remove by inserting an object, cube, once again, and then we move it in place. Something like that, maybe. Yeah, and then we get a bit more material here. So I want it to be, of course, flexible enough to actually fit, but I don't want it to break either. So I need some thickness to it, I suppose. Let's measure this once again. Yeah, it's almost 4 millimeters now. Maybe it's too much, I don't know. We'll try this, I think, and see if the concept of it all works at all. Yeah. So let's get to it. Okay, so we are in Flash Print 5, the slicer software for my printer. And I have imported the 3D model file, so let's get to slicing. I think that I have my misspelled experimental 2 profile, which has some adjustments. If you're interested in which, then check out my previous videos with 3D printing, and you will get the sort of chronological evolution of this said slicer profile. But basically, I've settled on a print temperature of 245, except for the first layer at 255, and then a platform temperature of 90. I have 0.6 millimeter nozzle, and I will be printing it in PETG. So I think that's a good choice since it's pretty sturdy and flexible at the same time without breaking, which is probably good for a print like this, I think. And I have a variable layer height selected. I saw some video on YouTube, I think, mentioning that maybe this is a good idea for many prints. So I suppose I can set some layer heights here, but I think it's automatic otherwise. And I have a very slow print speed because I want high quality prints. PTG I had some issues with, and you can't print too fast with it. However, the travel speed is at 250 to reduce oozing and stringing. Yeah, on the infill, I think maybe a 50% infill rate should be good. I'm trying 3D infill Yeah, let's slice that. And preview it. So it looks pretty nice over here. Maybe we can I don't have any brim or anything like that. I don't think I will need it for this tiny print. Um, Even with the sharp corners. So yeah, I will send this to the printer and we will see what happens.
Alright, so I did have a little bit of an issue with well, let's remove some debris. I did have a little bit of an issue with the first layer, as you maybe saw, and well, I haven't cleaned this. Maybe I should have cleaned and apply a new glue or something as well. So, but this came off nicely. So the problem is the first layer, the the filament doesn't really want to stick at all points here. Maybe it isn't completely flat, so it doesn't stick too well if it's too high above or something, the nozzle, or yeah. But this is what it looks like. We have some spiderwebby stringing, but that's a bit of microplastics. But overall, even with the issues here, it does look pretty good after the first layer or so. And yeah, one corner did lift a little bit here in the beginning, but yeah, I think we're good. So let's try this out now, shall we? Okay, so we have the infamous drying rack over here, and the printout. It's sturdy, that's for sure. So this was with a 50% infill, and it feels pretty solid. A little bit gluey here from the from the first layer. Let's try it out. So here comes the test. Yeah, so over here it's a bit too wide. Of course you could squeeze them together, the bars, but I think that, yeah, look at that. So it does bend a little bit here, but then you can, yeah, of course you can then move it to the side, and here it sits very nicely here actually. And then when you want to remove it, you can of course remove it over here, but you can slide it to the middle and just take it off. Yeah, so I'm pretty glad I did allow for a little bit more overhang here, because yeah, you sort of take one side first Oops. One side first, and then you just slide on. And the same goes when you remove it. So, yeah. I don't know if it will hold the weight of these, but... And then you can slide it, even if they're not parallel, it will pull them together. Of course, yeah, I think PTG is a good choice, I hope, because it's a bit more flexible. It doesn't break off. And even here in the middle, it sits pretty nicely. So, allow me to do the test. Let's place it over here. Yeah. Look at that. So now they won't open. And if we slide it over here, it's a very sturdy, actually. Great. It works better than I thought it would. And of course we can print another one and have two. So you just slide on, one to the left, one to the right, and you just put this away until next time. And next time you want to bring it out, you just bring it out, and this will hold the flaps or wings connected, so you won't get the issue where they open up and cause a mess and a lot of unwanted sound as well. So yeah, I'm very pleased actually. Maybe I should have made a hole or something somewhere so I can hang it by a wire, but of course on the other hand it can just sit over there instead while you're hanging your clothes, so you don't have to have a wire or a string or anything attached to it. Yeah. That's great. So there we have it. I will put the 3D model up on my Printables, on the DrMBalmer channel Printables account. So go check it out there. And this is a very simplistic thing, and it took about 26 minutes, I think, to print. So yeah. And I like the, apart from the first layer quality here, if we ignore the first part, the wall is pretty nice. The stringing was very thin and spiderwebby like, so it was easy to remove. It wasn't an issue with that type of stringing. The walls are not 100%, but they're pretty good, especially considering that we did have some one part lift off the base plate or build plate. And here we got a nice, almost ironed looking top layer as well. Yeah, very nice. So 50% infill seems to work just fine. I suppose if you decrease the infill value, you can get this to bend a bit more. If that's good or not, I don't know, but 50% 3D infill seems to have worked.
Great. But we're not actually done yet. Remember I said that this is, well, one part of the issue. The other part is if you have broken sort of metal bars, the thin ones, they tend to break off in the joints with time. Now this rack hasn't got that issue yet, but my father has a drying rack which has exactly that problem, and for that reason I think we should browse around on Printables and see if we can find interesting solutions for that problem. So let's do that next. So with that success behind us, I have been looking about a bit on Printables regarding the other problem with the metal strings or wires getting desoldered, or where the solder joint detaches. And well, I found a couple of different solutions, but I think this one is kind of well, it appeals to me in some way. It's pretty simple. It requires two M3 bolts and nuts, and I think I have bought some. I just have to find them. Ideally, a length of 7 millimeters. Get a flush design, but okay. So works best if the wire has a diameter of 2 millimeters and the frame tubing 12. And I think this is a standard European drying rack. Might be different in the US, maybe, as the creator of this original model also writes here. Bottom part can be printed horizontally, laying on the bed, while the upper part should be printed on the side. See slicer screenshot. In this way, no supports are needed. So it should be laid out like this to print well, I think. We can see some examples here. Either this way around, or let's see here, this way around. So yeah, I wonder how it will hold up. So there's two pieces to it, and then you have two screws. Yeah, so I think we should try this out. Seems to be an easy enough design. Right. So yeah, let's get to it. I will download these, and we shall print them. Right, so this time around I'm trying to print only the bottom part, the small piece that failed, starting with that alone. And I've added a brim. So first we have some pre-extrusion. Let's see how that goes. Probably it will
dragged around. I added some more glue. Yeah, the pre-extrusion is dragging along a bit, but I think it's okay. Let's see, so this is the brim, I think. Let's see how it handles. Okay, this is too dark. I also moved the 3D model a bit to the back. Maybe if it's a little bit uneven, the bed, then maybe it's better back there. Since the larger model didn't have any particular issues over there. Well, it looks better than it did previously, so I'm cautiously optimistic. And I maybe have a clog or something, a nozzle, but the pre-extrusion always it fails for a bit, and then in the beginning, but once it gets going, it sort of runs nicely. So yeah. How about that? I will first try to remove the pre-extrusion. Yeah, I think I might have to wait for this one to cool off properly. Yeah. Got it. So yeah, it well, let's remove the brim. So the brim also went under the bridge, so to say. Yeah, this part wasn't too perfect, but okay. At least we have something. So let's also print the other part, the larger part, and see if that goes well. There's kind of a blob there. Oh, that doesn't look any good. No. Yeah, I managed to, using my snips, I managed to pull out some amount of plastic from the nozzle. Let's see if that makes a difference. At least just looking from the pre-extrusion, it actually did stick, and well, it looks better now. I moved the model back a bit. And decreased the Z height by 0.05 millimeters. And it is finished. And it does look a lot better once I removed some debris or residue from the nozzle, just from the outside. Alright, let's just quickly inspect it. Yeah, a little bit of stringing here, but it's all pretty good. A little bit of a strange thing here, but it's okay. Seems sturdy enough. Alright, so let's have a closer look. So at the bench, let's see what we got here. We have two pieces, and yeah, well, the quality is okay. We can see here that, if it focuses, the nozzle did drag a bit, so I lowered the offset a bit, but maybe won't have to. But well, it's a print that fits for our purposes, I hope. And this small piece, well, it actually turned out in some way, so I hope it will be good enough. And this on the Printables page, it said that it's made for M3, and I do have an unopened little box of M3 nuts and bolts that I bought from AliExpress at some point. And it has different sizes, so M3 by 6 millimeters and 8. On the Printables page it said ideally they should be 7 millimeters, but maybe the 6 or 8 will be fine. However, I suppose we should be able to use cable straps or zip ties or whatever as well to just... that should work. I bought some very colorful ones from AliExpress. They were about, of this size, they were about $1 per bag of 100 pieces, so that was okay. And they were a bit more cheerful looking than the standard ones. So and these are 10 centimeters in length. But we'll start with the screws, I think. Why not? There we go. Unfortunately, the wall here has collapsed, so they're a bit mixed up, I suppose. But that was probably expected when shipping things like these from countries far, far away. Well, I suppose the nuts are the same size, and they should ideally fit in here. And they do. So that's a good start. And then I suppose the shortest one is the 6mm one. And then we have the 8mm one. We'll start with this 6mm one maybe. So let's see here. This should go... yeah. Okay, so it doesn't hold the nut. Right. First we have to make sure the nut is actually getting through. Now let's hope it can focus. I should bring a screwdriver. Oh wait, no, it's an Allen key. That's very unfortunate. It means I will. It means I will need an Allen key. Now I have this screwdriver, but where is the casing for it with all the bits? Give me a moment. I didn't find the case for this one with all the bits, but I did find one of these. Now I suppose, I don't know, this is maybe not the metric one. Let's see if it fits. Yeah, I suppose this one might just fit. Yeah, that's great. Yeah, it holds it in place. So that's pretty nice. Let's see if it actually works. I suppose I will have to do all of this again at my father's place, but I'm just testing it out here, and then we shall migrate to his drying rack. Yeah, so I think the 6mm would be enough. The 8mm sticks out a bit, so maybe we should go with the 6mm one. If this fixes the issue, my father will be happy. I think. I hope. Now he has a screwdriver set with Allen keys. That much I think I know. So this one went in deeper than this one. Okay, but we should not over tighten anything right now, but right. Now let's go try it out at my father's place. Right, we are at my father's place, and I'm doing a voiceover here because of some, well, unexpected background noise, let's say. So as you can see, we have one rod here, one metal rod that is loose, and it has desoldered itself, so to speak. And now we have our little contraption here, into which the rod shall enter, and then we will try to fasten it to the larger rod. But as we can see, I'm having a little bit of trouble doing it with these fastened, so I will probably have to unscrew those. Yeah, so here we are. And well, let's try to just get it into place first. Yeah, like that. And it sits pretty tightly, so it could work. However, I'm starting to notice that there's a bit of an issue. Sorry for the camera being off a bit. I'm holding it with one hand. I didn't have any tripod at my father's place, unfortunately. But I'm starting to realize there's an issue where the rod is a bit too long. So I will have to sort of cut it a bit with some side cutters or something, and hopefully make it work. So yeah, it's a bit too long. It doesn't fit together with the plastic part. It would have had to be a bit deeper down or something. The cutout that is on the printout, there's a cutout for the rod, but it doesn't fit in between. So yeah, we'll have to cut off a little piece of the metal rod. And here we are. I have just cut it off using some side cutters. Couldn't film that part with one hand though, so it was unfortunately not included, not in recorded. But as you can see, the rod is a bit mangled, and now I think it's short enough so that it will be supported by the plastic part, but not be in the way under the other metal rod, the thicker one. Yeah, you can see it's holding up pretty nicely on its own. So let's try to screw it back on, and the little smaller plastic thing with the nuts that will hold it in place, and I will fetch the screws and we shall attempt to screw it in from underneath. And this will be very interesting. If it works, it would be great, because this drying rack has been broken for years. But only one rod did fail in the solder joint so far, but it's a bit sad to see it every time being broken. Therefore, yeah, if this works, it would be great, and it seems to work. Yeah. So I'm
pulling the rod a bit, and it seems to be holding up. Let's try to close the flap a bit. This is what it looks like on the other side, on the underside. So yeah, it really does work. So my attribution goes to the creator of this 3D model. Unfortunately, I had to cut off a bit of the rod, but I suppose that's okay. It does move about a little bit, but it doesn't come out of the contraption. Now let's conclude this video. So we had 2 3D models in this video, and well, the first one was my little 3D model on the retention clips for the drying rack, so that the flaps or wings of said rack do not open while you move about the rack and try to set it up. So actually I'm pretty pleased with how these came out, and I see no issues when printing in PETG, at least. I haven't tried in PLA, so PETG it is. As I understand it, bends a bit more than PLA, while PLA breaks a bit earlier when you apply some force onto it. Tensile strength, maybe. I don't know if that's the correct terminology, but anyway, yeah, it was an easy enough 3D model to make. It seems to work well with the sort of standard European drying racks, as I understand it. 12 millimeters in diameter bars, but of course they vary a little bit, but seems to work okay. And certainly I haven't had an instance where these clips fall off. So I printed actually 2 of these, and I used 2 on the drying rack of mine, and it works pretty well actually. I haven't had any issues so far. I don't know how long they will last. Will they sort of become loose and fall off with time or not? But yeah, I'm very pleased, and I will upload the 3D model to my to the DrMBalmer Printables account. Now, the second model was from a Printables user called Jimbo with a 0 as the last O character. So attribution to Jimbo or Jimbo. You will find the link to that creator's Printables page as well in the description of this video. So do check out the description for direct links. Also, I'm pretty impressed with that model. It's simple, it works. I had a little bit of issues printing it at first in PETG, but that was perhaps more because of issues that I had with the printer and maybe some clogging and stuff like that. Once I cleaned the build surface and removed some PETG residue from the nozzle, it all worked a lot better. And the model itself, I mean, these are small things, so there's no real reason to talk about, the consumption of PLA or PETG, the filament consumption. These are very small models, so you can easily print 10 or 20 of them without having any issues. And I think that these 2 models that we printed today are pretty good candidates for what to print when your filament spool is running out sort of situation. You can always print one of these, and once the filament runs out, yeah, you simply toss that clip or retention bracket or whatever, and you have 9 working and the 10th not, but that's not a problem. So yeah, definitely on my list of very useful items. And I'm happy to have repaired my father's drying rack, which had the issue where the sort of one of the strings or rods had well, the solder had failed, and it was sort of useless and annoying. Now my father is very happy. So yeah, and he also got a couple of the retention clips that I made myself as well. So there we have it. I hope you have enjoyed the video. Look forward to more upcoming projects and videos for sure. Thank you all so much for watching. Have a nice day. Bye bye.